All right, we are going to finish up 11.7, which finishes chapter 11, and we're going to have a test on Friday, right? Yeah. So we encountered several formulas, basically, or conversion equations last time. We talked about converting in and out of cylindrical into our rectangular system. We did the same for spherical coordinates, in and out of spherical coordinates into our rectangular system. And where we are now is that we are going to convert between spherical and cylindrical. So we're going to go back and forth between those two. We mentioned as we were working some similarities between some of the equations we were seeing and how they related to rectangular coordinate systems. So let's take a look at how all of that sort of pieces together. So we have two sets of conversions. Our first one, hang on. Yeah, that's right. Spherical to cylindrical, as long as we're working with r is greater than or equal to 0. And of course, if it weren't greater than or equal to 0, we'd find a corresponding point where it were in order to triple. So r squared is rho squared sine squared of phi. We mentioned last time theta's theta. It's good stuff. And z is rho cosine phi. And then if we go cylindrical to rectangular, to spherical, again, r is greater than or equal to 0 to make it work. Rho is the square root of r squared plus z squared. Theta is theta. And phi is the arc cosine of z over the square root of r squared plus z squared, which would be rho, obviously, is there as well. So, it's rho. All right, you ready to try some? Yes, sir. David, do you have a question? I'm sorry.
Why is it r squared equals rho squared sine squared phi and not just r equals rho sine phi?
Why is it written that way? It's a good question. I'm not sure why they have it written that way. I hadn't considered. I just used what they had in your book. I'm going to guess that the sign value could be negative, and we don't want that to happen to give us an r value that would end up being a r value that would end up being negative if we went through that road, down that road. So I'm going to guess that's probably why. Looking at it, because that's the only thing that would make a difference, right? Because we've already said that r is positive. We know that rho is positive from what we worked with last time, I believe. So I think we're trying to make sure that the sign value that we get out of there is a positive value. I think so. I would guess yes. That's got to be true. I mean, yeah.
Are we sure it's phi? Because every time I try to put phi into any of the programs and it substitutes it, that symbol does not match at all for phi or the capital phi. It's just an angle measure.
Yeah, it just means it's an angle. So I'm not sure what you're seeing.
I know that's
like
a great
on
letter. I just know that's.
You said the computer programs aren't going to have. It's going to look different. She told us about that.
Yeah. Are you talking about what it looks like, Ethan?
Yeah.
So it looks like this if we're doing it in text print. Like if you look in a textbook, it looks like that.
Okay.
Is that what you're talking about? Okay. Yeah, it will look different in text than it will when people write it down. And again, I don't really know the reason for that, but I remember thinking the same thing when I was in your place. Like, why do we have so many different ways of writing the same thing?
I think there's actually a symbol for that matches it.
Yep, I bet that there is. Yeah. Okay, so let's do some conversions. I think I have space for one of them on here, so we'll give it a try. On the page. So this is number 9, and we're going to convert. Again, I'm kind of abbreviating the direction sets, but we're going to convert cylindrical to spherical. And we're going to be using the ordered triple 4, pi over 4, and 4. And I did this last time where I identified what within the system which letters we were working with basically over here, just to remind ourselves. So this is R, theta, and Z, just as a reminder. One of these is easy. Which one? Theta. Fantastic. So we need to find rho and we need to find phi. So what is the equation that we had for rho of the several that I just gave you that would be applicable here? We could use. Yeah, square root of r squared plus z squared, and they both happen to be 4s, right? So 4 squared plus 4 squared. 32, right? And what is that when we simplify it? Sorry, there's my square root. 4 square root 2, thanks. Yes. Cool, there's rho. We already said theta's theta, so I don't need to worry about that one. Phi's fun. It's the arc cosine of 4 over the 4 square root of 2, exactly. So this is the arc cosine of square root 2 over 2. Do you know what that angle measure is? What is it? Pi over 4. That's right. Pi over 4. So the corresponding ordered triple and spherical coordinates would be 4 square root 2 and then pi over 4, pi over 4.
How do you know that that's pi over 4 and not negative pi over 4?
For arc cosine, when we're dealing with cosine and arc cosine specifically, it's the top half of your unit circle values. So in order for it to be a one-to-one function, you have to isolate it. So you're right, cosine would work for that, but not for arc cosine. Yeah, it's just the way that they define the function. All right, one more example and we'll be finished with this section. This is number 10. I bet you can tell me what my directions will say. What are they going to say? You betcha. Convert spherical to cylindrical. And my ordered triple is 4 pi over 18 pi over 2. And that would mean that we're working with rho, theta, phi. So we need r. What was our equation that dealt with finding r? R equals the square root of what'd you say? Yeah, so, and if as we mentioned before, well, I'll write it that way. Rho squared sine squared of phi. Oops, not theta, phi. And as we mentioned before, squares and square roots are going to cancel out nicely as long as the sign value is positive anyway. So what is rho? Let's see, 4. So I have 4 squared, so that's this. And then I have the sine squared of pi over 2. What's the sine of pi over 2? 1, right? So this is actually just 4. Very nice, isn't it? Poor, did somebody say poor sine? Yeah. Okay. Theta, what's theta? Theta, pi over 18. This amazing value, right? Pi over 18. And then we need z. How are we going to find z? Rho, what was that? Cosine of phi. Fabulous. All right, so we said rho is 4. And cosine of what? Pi over 2. What's the cosine of pi over 2? It's 0. So we get 0 on this one. So we have 4 pi over 18. Yeah, say that louder, David.
So it's on the xy plane.
It's on the xy plane. If z is, or if the z value is 0, we're on the xy plane. What's that? It's very much collapsed, isn't it?
It has no
Depth. Yeah, it's not 3-dimensional. It's a 2-dimensional object. Andrew?
So I asked last That's how you get negative spherical clouds. It measures from the negative z-axis, doesn't it? Not from the xy.
It may.
Because if phi is pi over 2, then that would put it right on the xy.
Yeah, I think you're right.
Okay.
Yeah, there you go. Good job, Andrew. Way to make me not have to go find the answer. I appreciate that. Super helpful. Yes, sir.
Okay, so if on the test, instead of rho for that first value, I put r, are you going to count me off?
Okay, well, where would you like to put the R? Because I know what you mean.
R theta phi is what I'm used to, instead of rho theta.
I need you to be careful with R because R means different things, right? There's an R in cylindrical and there's an R in spherical, and they are not the same value.
Correct.
So
Capital R.
let's use rho. Help me out here, Kyle. Help me out. All right, any other questions? I'll put back on the homework set over here, but any other questions before we start looking at review stuff? I am. I feel like that I'm asking you to do a whole lot of problems, and to not take it up would be not fair. So yeah, I'm going to take it up.
How difficult is it?
All the problems feel a lot like the ones I just did. They don't, computationally, they don't take that long. There's a long list of problems, but computationally, they go pretty quickly.
I'm assuming they're all